Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 18 in our tutorial series where you are learning to build a non-axis inertial measurement system. I am going to need you today to pour yourself a nice big mug of iced coffee, and I'm going to need you to get ready to visualize Yaw and Pitch in Vpython. Okay, just a reminder as to what we are doing. We can come and sort of pick up where we left off last week. And where we left off last week, let me get out of your way here. Where we left off last week was we're looking at creating a visualization in Vpython that will track our breadboard as it moves around in the real world. What we saw last week is in order to do that, you've got to be able to understand some simple trigonometry. And then after we learn the simple trigonometry, I explained that the key to getting the simulation to work is you've got to think of your rigid body, which for us is our breadboard. You have to think of it as having a vector coming out the top of it. And what you are describing to Vpython is you are describing the x-coordinate, the y-coordinate, and the z-coordinate of this vector, of this arrow that is coming out the front of your rigid body. Just to renormalize you to the scale that the Vpython sort of uses, this is the positive x direction. It comes up in a default mode where this is the z direction, and so that would make the y direction up. And so the Vpython sort of has a y up orientation. Then if you go x to y, z is coming back this way using the right hand rule. So taking the yaw as psi and the pitch as theta, what we showed last week is there is some very simple trigonometry that would tell us the x, y, and z location of the tip of this vector as x is the cosine of psi times the cosine of theta, right? This cosine theta takes the vector and drops it down to the xz plane, and then you can get the x component as taking cosine psi times cosine theta. The z component is sine of psi times cosine of theta. And then it's pretty easy to see that if this is the vector that is like this at a pitch of theta, to get this y value, this up value, then that is just the vector times the sine of the pitch. And if you don't understand this, go back and look at the last lesson, but these are the kind of three things. The position as we rotate around is shown here. The position of the tip of this vector is x, y, and z. Okay, so now let's code this thing up. We've kind of done the hard work, which is the trigonometry. What we need you to do now is, if you remember a couple of lessons ago, we switched over to PyScripter. It's still Python 3.7, it's still Vpython, it's still all the things that you are familiar with, but what is different is simply that PyScripter is a little bit more full-featured editor, and in particular it makes it easier for me to do the code and talk at the same time, and you still be able to look and see what I'm doing. And so I hope you guys have moved over to PyScripter. If you haven't, I think it was probably somewhere around lesson 16 where we showed you how to do that. Okay, so now let's call this thing up and let's show you how we can do this simulation. All right. First of all, this is all about Vpython, so the first thing we need to do is from the library Vpython, you want to import everything, so import star. We're also going to need to, from time import star, because you never know if we might need to put a delay in there. Asleep, you have to have the time library. We're going to want to use NumPy, so from NumPy, or no, just import, I'm sorry. We're going to import NumPy as NP. And we do it that way so that anytime I want to go to the NumPy library, I've just got to type in NP. It's a little bit easier. I ended up with some nonsense there. Okay, are you guys able to see this okay? Or I think you should be able to see that. I hope so. All right. Import NumPy as NP. Those are the libraries I'm going to need. I'm going to import math just because before this is over I might need to do some heavy lifting with my math. So NumPy, again, that helps us deal with arrays, and so as we really get in and start doing these array functions, the NumPy is easy. Okay, I'm going to kind of set up the view so you have a nice view once Vpython starts showing the visualizations. And so if you think about this breadboard, it is about 6 inches across, and so how big do I want my overall view window to be? Well, like plus or minus 5, and so I can do that by saying scene.range equal 5, and that should create a visual box that's big, about the right size for us to see all the action that's going on. Now, remember that Vpython wants to do all the trigonometry in radians, and it's a little easier sometimes for us to think in degrees, and so we need to be able to switch back and forth. So if we're interacting with it, we can interact in degrees, but when we go out to do the functions, we can switch back to radians. And so I need a constant that is just 2 radians, and 2 radians is equal to 2 times pi, which we get by calling it np.pi. That'll pop a pi value in there for us, divided by 360. So if I take a degree value and I multiply by 2 rad, it will give me the radian version. I might also want to go the other way, so I could say 2 degree, that is equal to 1, the inverse, 1 over 2 rad. So with these 2 little helper constants, it'll be easy for me to go to and from radians and degrees. Okay. I want to kind of get my view on my scene, and so this is just kind of like which direction you want to be looking towards when you open up that visual window. And so I'm going to say scene.forward is equal to the vector is equal to the vector, and I'm just going to say -1, -1, -1. So that'll kind of put me out at x is equal to 1, z is equal to 1, y is equal to 1, and kind of looking back at the axis. So this should give me a view where I can kind of stay oriented pretty well. Hope that makes sense. Okay, now how big do I want my scene? Well, my scene dot width, I'm going to make it about 600 pixels. Scene dot width equals 600. I don't need those parentheses. And this is in pixels, and then scene dot height is equal to 600. This is just all bookkeeping. This is just kind of setting up a nice view so that we'll get a visualization that's kind of easy to make sense. Now, I like to stay oriented, and so I always want to see my x-axis, my y-axis, and my z-axis. So I'm just going to put in 3 fixed arrows just so no matter what craziness happens, I can sort of see the Vpython coordinate system. If you don't like these later, you can take them out, but it is almost always helpful in debugging to have these things. So I'm going to have an x arrow, and that is going to be equal to, it's going to be an arrow, and then I like the length is equal to 4. Why 4? Well, if my breadboard is 6, 4 would be a reasonable thing for my length of my arrow. Shaft width, this is like how heavy the arrow is equal to 0.1. Is pretty good. And then I'm going to say color equal color dot red. And then where do I want it pointing? Well, if this is the x arrow, it should be pointing along the x-axis. So I can tell it the axis is equal to vector. So what vector would point along the x-axis? A vector has three directions, x, y, and z. And so what would the x-axis be? It would be 1 along the x, 0 along the y, and 0 along the z. And so that should give me a red axis along x. And what I'm going to do is x, y, z, RGB, because I think, I always think red, green, blue. So x is going to be red, y is going to be green, z is going to be blue. Now this next one should just be almost the same as this. So I'm going to just copy and then I'm going to paste. Only this is going to be the y arrow, and it is going to be along where 0, 1, 0. So that would be 0 in the x, 0 in the z, and 1 up. So that would be an up pointing arrow. And then finally, you guys tell me what this one's going to be. This will be your z arrow. Z arrow, all the same. I don't want all these red. This one was supposed to be green, red, green. This one is going to be blue, B-L-U-E. And this one, since it's going along z, it's going to be the z arrow. And that would be what? That would be 0, 0, 0. Or 0, 0, 1. I'm just realizing you guys probably cannot quite see this, huh? Okay, I think you can see it now. I'm sorry if a couple of those things you didn't see perfectly. But let's look. X arrow is going to be the vector 1, 0, 0. The y arrow is going to be along the vector 0, 1, 0. And the z arrow is going to be along the vector 0, 0, 1. Okay, does that make sense? Let's just run this and just make sure that we get a vector. Okay, so I'm going to come up here to this little right arrow, and I'm going to run it, make sure that we get kind of a coordinate axis. Okay, yeah, that looks pretty good. I could even zoom in on it a little bit. And so let's check that right-hand rule. If I go from red to green, that's going from x to y, then z would be where my thumb. So everything follows the right-hand rule. That looks pretty darn good. Okay, so let's continue on here. I think what I want to do now is I want to kind of begin to formulate. Okay, so those are the fixed axes, x, y, and z. Those are the coordinate axis of Vpython. I want to kind of create a similar set of axes, but these are for the body. And so I'm going to have kind of an arrow in this direction, an arrow out the side, and an arrow that goes up. And the difference though is that those are going to move within the coordinate system. So those are not always going to be along x, along y, and along z. So what I'm going to call the first one is this one that is coming this way, I'm going to call it the front arrow. Okay, I'm going to call it the front arrow, and that would be the arrow that is pointing out the front. And so we will call that arrow, and then that is going to be equal to arrow. And again, I am going to make, let's see, these up here I'm going to make 2. Those are really, I'm going to make these 2. Because I just kind of want them to be not that big. I just want them to kind of be a reference for me. And so the front arrow, I will make length equal to 4. Okay. And I'm going to make the shaft width equal to 0.1 again. Okay. And then this time the color, I want it to be different than the other one, so I'll say color.purple. All right. So that's going to be a longer arrow, and it's going to be pointing out this direction, and it's going to be purple. So that's the one sort of showing me where the breadboard is going to be pointing. And then on that one, I'm going to start it pointing north. And remember, we call north that x-axis. So the axis will be along the x-axis, which we are going to call north. And the axis is equal to vector. And then how do we do the x-axis? It is 1 in the x direction, 0 in the y direction, and 0 in the z direction. So that should be this vector here pointing along the x-axis. Maybe if I oriented this as I'm building it, okay, right, this is the positive x-axis, and this is the arrow pointing along the positive x-axis. So now I've got the real world kind of, as I'm building the virtual world, I'm kind of lining it up logically with the real world. Okay, so that was the front arrow. I also want an up arrow. Oh, what did I do there? I somehow got in the wrong space. Okay, axis equal vector. All right, we got that now. So now I'm going to have an up arrow, and that up arrow is going to be equal to an arrow, creating another arrow. Okay, and this one I'm going to make smaller, length, because I really want to kind of watch the thing based on this vector, and then I'll just put a small up vector just so I can kind of see the whole coordinate system. So length is going to be equal to, let's make it 1, okay, and then shaft width is equal to 0.1, and then color is equal to color dot. What do you think for this up arrow? Color dot magenta. Okay, color dot magenta, and the axis is equal to vector. All right, now this one is the one pointing up, and so up would be what? Up is y in this crazy world that is Vpython. I'm a math teacher. I like x and y in the plane, and I like z up, but they're kind of in a y up orientation. We will adapt to that. So for this one, the vector for y would be 0, 1, 0. So that would be the up direction. And then also I want a vector coming out the side. Okay, and if this is x and this is y, then z is coming this way. So I want kind of a z vector, which I'm going to call the side vector. Now, why am I calling it side? Side arrow. Because this might not always be in the z direction, right? As we move it, it's going to be in other directions, but it's always going to be coming out the side of the board. So side arrow is equal to arrow, okay? And this one, I think I will make a length equal 2. All right. I have a shaft width of equal to 0.1. A color is equal to color dot. What do you think on this one? Orange? Okay, color dot orange. And then the axis is equal to the vector. Okay, now what is coming out the side? Coming out the side would be z, and so we will call it 0, 0, 1, and that should be pointing in z. All right, let's go ahead and run this. I like to run it just to see if I've made any mistakes along the way. Okay, I kind of like this. All right, so you see we've got the purple is up, or the what? Oh, that's the magenta. Yeah, the magenta is the up arrow, and then this is the front arrow, and then this is the z arrow. And so we've sort of lined this thing up with the x, y, and z axes to begin with. So we're kind of starting in the north direction, pointing north, and we're starting with it dead flat, no roll, no pitch, pointing north. So that's going to be our starting position. Okay, so we got kind of our frame built. We're really moving along right now. Now let's see if we can animate this thing. Okay, so we want to begin to animate it. So I've got a frame now. The next thing is I want to animate it. And that means I'm going to just need a loop where I'm going to continue to loop. So I'm going to say while true. Okay. Maybe it should be uppercase true. While true. All right. Okay. While true. And then a while loop begins with a colon. When is true true? True is always true, so this is going to loop forever. It's going to be kind of like your void loop in the Arduino. Okay. Now I'm going to start by giving it a pitch. And let's start with pitch 0, and then we can come back later and we can change the pitch. But let's just see if we can do the easiest case, which we just want to rotate this around from 0 degrees all the way around to 2 pi. Okay, we want to rotate it one complete rotation, 2 pi, and then see if we can visualize that. All right, so we are going to start with 0 pitch, because that will be the easiest to check out our code. Okay, so we're going to do that here by saying pitch is equal to 0, but then I'm going to multiply it by 2 radians because I'm saying it's 0 degrees. Well, it's also going to be 0 radians, but I'm just reminding myself that we got to convert everything to radians. And by doing this, then if I put something other than 0, it will work as well. Now I am going to do a for loop. So I'm going to say for, and what is it that I want to change? I want to change yaw. Okay, so I'm going to say for yaw is equal to what? For yaw is for yaw, and the way a for loop is done in Python, it's for yaw in, and then in np.range. So this generates your range. First you start with where you want to start. Your first value in this for loop you want to be what? 0. And then you want to go to what? 2 pi. So this would be 2 times, how do we do pi? np dot pi. You could just type in 3.14 or 3.141592654, but it's easy for me to just say 2 times n pi. And then what's the step size? So it's the start value, the stop value, and the step size. I think I'm going to do a step size of about 0.01, and that should make it a nice, slow, smooth rotation. All right, and a for loop, you will have a colon to start the for loop. And right, the indentation is how you keep track of where you are. So now we're indented underneath the for loop, and we can put the code now that we want in the for loop. Anytime you animate a scene in Vpython, you have to give it a rate command in the part that's looping. So here's where we'd need the rate. I'm going to put a rate of 50, and that would be like 50 frames a second, so that's going to be moving pretty smoothly, or 50 times through the loop a second, so that should be nice and smooth. That's a pretty good thing to try. Okay, now is where we have to tell it where the tip of this arrow is. Okay, and the tip of the arrow depends on pitch, and it depends on yaw. Okay, it also depends on roll, but we haven't dealt with the trigonometry of roll yet. We've just done pitch, and we've done yaw. And so I need to tell Vpython where the tip of this arrow is. It needs an x value, a y value, and a z value. All right, and so let's put that in, and we are going to put that as the k vector. Okay, and so this arrow that is pointing forward is going to be what we call our k vector. And for that vector, we've got to tell it the position of the tip of the arrow. Well, where is the position of the tip of the arrow? We derive that in lesson number 17. X, y, and z. Okay, and so we're going to say k is equal to the vector that has an x value of what? Well, cosine of yaw, which is psi, okay, times cosine of pitch, which is theta. That's the x value. All right. What is the y value? Well, the y value is up and down. That one is pretty easy. That is just sine of pitch. If you don't understand this, go back and watch the last lesson, okay? And then the z value, you know, this value coming this way, the z value is sine of yaw, comma, cosine of pitch. And I think I probably was closing my parentheses as it was closing my parentheses, so I probably have way too many closed parentheses. I hate that auto finish feature because I want to be the one that does that. All right, so now I have defined this k vector, specifically where the tip in x, y, and z of that k vector is. All right. Okay, so that is going to take care of that. We also need to kind of do our bookkeeping on this, on these other arrows. Okay, and so I'm going to scoot this back a little bit, and we're going to have to do some right-hand rule here. So I know where this one is because I got that from trigonometry. Now I could go ahead and I could do the same thing. Do the same derivations, but I would have to start from scratch and derive this vector and derive this vector. Just like I derived this vector, I would have to do this one and I would have to do this one, and then I would get numbers like this. But there's an easier way, and that is if we understand what the cross product is. Okay, if we understand what the cross product is. The cross product, if you have two vectors and you say this vector cross this vector, it will give you the orthogonal vector, the vector that is perpendicular to both of those, and it follows the right-hand rule. So if I go this vector cross this vector, it's going to give me this one based on the right-hand rule. If I do this vector versus this vector, the right-hand rule is going to give me that vector. Okay, so it's the vector that the cross product gives you, the vector that is perpendicular to the two vectors that you're crossing, and the direction of that vector follows the right-hand rule. And so let's just kind of look at that, and let's see how it works. So I'm going to say, first of all, down here we're just going to play in the interpreter so you can see in real time what happens, and then we'll come up and code it in a minute. But I just want you to see how cross product works. So I'm going to import down here, or I'm going to say down here, and this is like writing a program one line at a time, from Vpython import everything. Okay, and now I'm going to say a is equal to the vector, and let's just say that I make a pointing along the x-axis, so that would be 1, 0, 0. That's my a vector. Let's say b is equal to vector, and this one is going to point along the z-axis. So that would be 0, 0, 1. All right. Now I'm going to say C is equal to the cross product of A and B. Okay. And so it's going to be the cross product of A and B. And if you go from A to B, then Z or C would be, the cross product would come this direction. So what would we predict the cross product would be? C. We predict that it would point along the positive Z axis. So let's see if that works. We're going to say C is cross A and B. And then let's say print C. Okay, that did not work. Let's see. A is here. Okay. Oh, and yeah. Okay, if this is x, okay, and then if I go to z, okay, xz, from x and z, the cross product is going to be down. The right-hand rule says down, and that's what it says. It's down y. So I wasn't thinking, but it did get the right answer. So let's try it again. Let's say if I go from x, let's see, that one was x and z. What if I go x and y? So I'm going to say a is equal to the vector. X is what? 1, 0, 0. All right. And then b is going to be equal to the vector. And this is going to be the y-axis. So this is 0, 1, 0. I think this is the example I was trying to do before. C is equal to a. C is equal to the cross of a and b. Okay, so this would be a and b. The cross product should be positive z. Okay, now let's print C. Okay, yeah, boom, 0, 0, 1. So that actually came out to be the z-axis. If this isn't making sense, go to the Khan Academy and look up the video on the cross product. The bottom line is if I go from vector A to vector B, that cross product is going to be orthogonal to both of them, following the rule of the right-hand rule. Why is this so important? Because now that I have this vector and I did all the trigonometry for this vector, I want to kind of get this vector and this vector for free, right? I want to get this vector and this vector for free without really having to think. So now I have this vector, this front arrow. Well, what I've got to do is I've got to kind of come up with the other ones now, all right? So I'm going to continue on with my calculations. So the first thing that I'm going to do is I'm just going to create a vector that's going to help me, just an up vector, just the always up vector. That's the y vector. That is going to be vector 0, 1, 0. So that's just the vector that is always pointing up. This one's not going to move around. But I need it, okay, because then what I can do is I can create this side vector, okay. This side vector here, the actual moving side vector would be my vector here, okay, crossed with my y vector. So S is going to be equal to the cross product of this vector, which we called the k vector, and the y-axis. So this is going to be the cross product of k and y. All right. So y is always up, and if I do k cross y, right-hand rule would put me out this way. Okay. And so that S vector is going to be the vector coming out this way, the moving vector coming out this way. All right. I also want the up vector. So I will call that V. The up vector is going to be the cross. Well, how would that work? That would be the cross between K and S would be V. So that would be the cross between S and K. And why would it be S and K? Because this is S, cross K, right-hand rule would put it up. If I did it wrong, I did it K cross S, it would point it down. So now I have V is equal to cross S and K. Okay? So now I have a moving vector that's going to be moving around for this direction, for this direction, and for this direction. All right. Now to bring the whole thing to life, I'm going to change, remember our friend, the front arrow? The front arrow dot axis. This is saying our old friend, the front arrow up here, I want to change the direction that he is pointing. So front arrow dot axis is now going to be equal to K, right? This moving one, K. And then I also want to move the side arrow. So our old friend, the side arrow, where do I want him to point? Dot axis says I want him to point where? Well, we just did it. The vector S. We calculated that with the cross product. And then we also have our friend, the up arrow. And his axis, or where he's going to point, is going to be in the V direction. Okay, so this X, Y, let's see if I can scoot back here. There's a fixed axis X, Y, and Z, and then we created a movable axis X, Y, and Z. And we got the K vector, this vector, by doing the trigonometry. And then we got the S, and we got the V by doing cross products. Okay, again, if this doesn't make sense, go to Khan Academy and watch the video on cross products. But it's just this is a way to take a very hard problem and make it simple. Okay, and so now let's run this thing and see how many mistakes I've made. Okay, it is not moving, which means we did make a mistake somewhere. So let's go back and start debugging our code. Go back to PyScripter-wise. Oh, we got an error. np.range. Oh, I'm sorry. If you just do a range in Python, it's range, but if you do a range in NumPy, it's a range. So this np.arange says start the loop at 0, loop all the way through 2π, and go in steps and increments of 0.01. Okay, let's see if this works now. Still not moving. Let's see if we had another error. Okay, something I didn't send 3 components to, so let's look back here. Okay, this is 1, 2, 3, comma. Ooh, I put a comma here instead of a time. So if we go back and look at our equations, okay, X was cosine pitch, cosine yaw, which we got, and then Y was sine pitch, which we got, and then Z was sine pitch cosine yaw. So that should have been a times in there. Did you guys see me when I did that? I hope you were yelling at me. All right, let's try it now. Boom! Look at that. Okay, look at that. That thing is spinning around. Okay, it's spinning around with a pitch of 0. All right, one of the things though that you can see that has happened is when we give this axis command, the axis command kind of renormalizes the length like we told it axis, and when we change the axis, if you don't tell it a length, it makes the length 1. And so we better kind of go in and set those lengths again. And so I'm going to say side arrow dot length, and we had made that 4, or no, the side arrow we had made 2, and then the up arrow dot length equals 4. So what we learn is that when you give an axis command to an arrow in Vpython, it like resets the length. And if you want the right length, or the length that you've been working with, you've got to go back and set it again. All right, so this should do it. And guys, if you need to kill a program under PyScripter, like this program is still running, the way you do it is Control F2, and that will kill your program. So Control F2 will kill a running Python program, and that keeps you from having to kill PyScripter and start it again. Okay, so side arrow length is 2, and I better spell this right, length, TH. So now this one should be spinning around, and the right size. Boom! Okay, do you see that? What that is doing is it is taking this vector, okay, and at 0 pitch, it is spinning it around. Okay, it is spinning it around at 0 pitch. And so the up arrow isn't changing, the pink arrow isn't changing because we don't have any pitch. Now the question is, we had done this math to include pitch, and so will it still work if I put, like, let's put in 15 degrees of pitch, and then let's see if it will still work. This is pretty exciting, okay? This is pretty exciting. So we're going to come back, Control F2 to kill the program. And now up here, instead of having 0 pitch, let's put in 15 degrees pitch. All right, and now let's run this. Boom! Okay, do you see that? Do you see that? Do you see how that magenta up vector is now tilted over? Okay, so what is this doing? This is going, like I put 15-degree pitch on it, and it's moving around, and that magenta arrow is the up arrow, okay? And also you can see, you see the blue, the side one is up as well. Wow, that is really, really, really going good. Okay. So that is 10. Let me make sure that I've got these things right. My front arrow is purple, and so somewhere I set something to the wrong one. Front arrow should be 4. Let's see, I have gotten a little bit goofed up here. Front arrow axis. Okay, this was the front arrow. Front. I didn't do my links right. Front arrow should be 4. The side arrow should be 2. And then I am really messing this up. So let's do all of our axes first. So I'm going to cut this. So I'm going to set the front arrow to K, the side arrow to S, and the up arrow to V. That all makes sense because we went through it up here. Now the side arrow length is 2. The front arrow length is 4. And then we're going to say the up arrow dot length. I should have set all these earlier, and I set one to a wrong value. Let's say the up arrow is going to be equal to 1. Let's say. Let's see how that looks. Okay, we will do a Control F2 to kill the program, and this one should have all the right colors and everything in the right place. Okay, yeah, so we've got the purple arrow is this long forward-facing one. Okay, and then the orange one is the side one, okay, and then the purple one is, or the magenta one is the up one. Okay, and do you see how magenta, purple, and orange all stay orthogonal? And what you can see is this long purple one, what I've done is I've tilted up by 15 degrees, and now I'm rotating around. Okay, let's try a different value here, all right? Let's try a different value. So I'm going to come back and Control F2 to kill the program. Okay, let's put it at 45 degrees. for the pitch. And so that is going to be a pitch of 45 degrees, and then we're going to rotate in yaw. So let's try that. 45, and then rotate. So let's see what happens. So it should be much more dramatic in the pitch. Okay, you see that? You can see that purple vector is up at 45 degrees, and that brings the up vector over 45 degrees as well. And then just the side vector, you can see the side vector stays in the XZ plane. So, man, play around with this till you sort of get yourself oriented. Okay, play around with it till you get yourself oriented. But what we can do now, I want to do one more thing. All right, I know this is getting a long lesson, but man, things are going to get fun and easy after this. The one other thing that I want to do is I want to come back to Python. I'm going to Control F2 to kill this. Let's go back in there now and let's put our breadboard in. We've just been rotating the axis system, but now let's go put our breadboard and our physical object back in the simulation, and then we should be able to see it move around. So what I'm going to do is I'm going to come back up here to the top, and I'm going to add some things. Okay, before we go into the loop, I'm going to add some objects. So what I want to do is I want to add my B board. Okay, my B board is going to be a what? It's going to be a box. And then how long is it? Length is equal to 6. Length is along the x-axis. Okay, width is in this crazy system along the z-axis, so width is equal to 2. And then height is equal to 0.2. That would be kind of like the size of the breadboard. All right. Now I should probably make it a little bit clearer, so I'm going to say opacity is equal to 0.8, so I can kind of see through it a little bit. And then where are we going to put it? We're going to put it at the position, and vector position is equal to vector, and put it at the point 0, 0, 0. So that's just saying put it at the origin. Okay, put it at the origin. Okay, so we created the breadboard. Let's create the sensor, the B&O 055 sensor. And so that we're just going to call for ease BN. And BN is what? It's a box. Okay. It has a length in the real world of about 1. It has a width along the z-axis of about 0.75. And then it has a height. It's very, very small, right? It's very small, so the height is 0.1. And now we've got to tell it where to go. Well, its position is equal to the vector. All right. So we don't want this at the origin. It needs to be, first of all, in the x direction. We need to move it about 0.5. Okay, we need to move it about 0.5 in the x direction. So we are going to say 0.5. And that way it is going to be forward. It is not going to be sitting there in the middle of the board, because here it's not in the middle of the breadboard. It's forward by about it's forward by about 0.5. Okay, it's also in the y direction. It's up, and the center of the breadboard is at 0, so the top of the breadboard would be 0 plus half the thickness. So we want to be at least that much. So the thickness was 0.2, so half of that would be 0.1. And then plus half of 0.1, which would be 0.05. Okay, and that is this height, 0.1, half of that plus half of this. So half of this is 0.1, and then half of this is 0.05. So that should put the bottom of the B&O 055 exactly at the same place as the top of the breadboard. Now that's X and that's Y. In Z, what do we want to do? We don't want to do anything because it's not moving this way or this way. It's in the center. So we can just leave that at 0. So that should take care of the BN. Now we also want to make the nano, so I will call it the nano. It's going to be a box. In that box, the nano has a length of about 1.75 inches. It has a width equal to about 0.6 inches, and then it has a height equal to about like the B&O, 0.1. All right, and then we got to give it a position, okay? And while this was pushed by 0.5, okay, while this was pushed by 0.5, this one is pushed in the x direction more like 2. Okay, so position is equal to vector. I want to offset that nano in the x direction 2, and then its y is the same as the BN. I got a goofy parenthesis up here, don't I? Better take that out. Okay. And then I can paste that there. And then similarly, no offset in Z. All right. I should probably give these things a color. So up here, I will say color equal color dot blue. And then that's the board. I'm sorry. On the nano, on the BN, comma, color equal color dot blue, and then on the nano, comma, color equal color dot green. All right. Let's just run this. It's not going to spin this time, but let's just make sure that we kind of got something that looks like this. All right, the axis is going to spin, but the nano's not. But let's just make sure that we got something that's kind of like not going to error out before we go any further. Okay, so you see we've got the breadboard built, and it's pointing along the x-axis like we wanted. Those things are all looking good. Okay. So now let's animate it. And the way we're going to animate it, I don't want to have to animate each one of those things individually, so I'm going to create a compound object, and I'm just going to say I'm just going to call it my object, my obj, and that is going to be the compound, the combination compound. My object is compound of what? Well, I've got an open parentheses, open bracket. I want my B board, I want my BN, and I want my nano. And so those three objects, the breadboard, the BN, and the nano, will all be part of this. All right, so now they're all part of it. Now all I got to do is just animate my object. And how do I do that? Well, I come down here, and as I'm setting these axis commands, I just say that I just animate that in the same way. I say that my object dot axes, I want it to point the same way that that front arrow does, which was K. Okay, and then also I've got to tell it for this object, I have to tell it which direction is up. Okay, so when you have a three-dimensional object like this as opposed to an arrow, you have to always also tell it what direction is up, but we've already calculated that. My object dot up is equal to what? Well, what was the up? The up was the up was the V. Okay, S was side, K was forward, S was side, and V was up. So I want to set the up for the object to V, because that's what I calculated. Okay, Control F2 to stop it. Okay, and let's run it. Boom! Do you see that? Do you see that? We have animated this thing, but I did one thing wrong. Okay, do you see that here my arrow is opposite the BN and the nano? And I kind of felt like I was doing it wrong when I did it, but really I moved the BN and the nano forward, where if you look at this, I should have moved it backwards. So let's fix that real quick. Let's come in, and that was up here where we created them, that where in the X direction on the BN where I said 0.5, I should have said minus 0.5, and the nano where I said 2, I should have said minus 2, and that will move them backwards in the negative X direction. So we're going to do a Control F2, okay, and now we are going to do a run. I think this one will really be right all the way around. Okay, this one is right. You see we're at 45 degrees and we are spinning around. Okay, nose up, right, nose up, nano down, and we are spinning around at a 45-degree angle. That is really, really, really slick. Okay, so guys, right now what we've done is we've just done the hard part of the math, where as we make up pitches, okay, as we make up pitches and yaws, this thing in the virtual world is going to those pitches and yaw. Can you imagine what we're going to do next? Instead of making up pitches and yaw, we're going to use the pitches and yaw that we are sending from the nano to Vpython, where instead of just sitting there spinning, it's going to spin in response to our motion. Okay, that'll be a big lesson. That'll be lesson number 19. Guys, I hope you followed this. It's just hard to describe in words things that are happening in 3-dimension. I've done the best that I can. Really, go back and look at lesson number 17. Make sure that you understand. Make sure that you understand the math that led to these equations. And then if you didn't understand those cross products, go in and watch the Khan Academy video, K-H-A-N, Khan Academy video on cross products, and then that will allow you to understand how we got these orthogonal vectors. Okay guys, next lesson is going to be a really exciting one. Hope you guys will tune in. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.